Class, good afternoon. Now, the topic which I am going to start today is complex numbers. Now, hope you all have heard about complex numbers, else, I will revise what are complex numbers. See, when you solve a quadratic equation ax square plus bx plus c equals to 0, where a is not equals to 0, your discriminant is b square minus 4ac. Now, you have done before that if d equals to 0, roots are real and equal. Whereas if d is greater than 0, roots are real and unequal. Now, when d is less than 0, roots are imaginary. So, you have to take this case, d is less than 0 in complex number, where the roots are imaginary. Now, roots are imaginary. Imaginary is something we say in the form of complex numbers. Now, in complex number, we have a number iota. We denote this by I. Now, iota is a number such that iota square is equals to minus 1. So, iota is a number whose square is minus 1. So, we have iota. Again, I am telling you, we denote this by I such that iota square is minus 1. So, we can have the complex number. Now, complex number is of the form a plus iota b, where a and b are real, belongs to reals. So we write z, we write a set c equals to set of all those a comma b such that you have z, or you can write a comma b, or you can write, or in better words, you can write c is set of all those z such that z equals to a plus iota b, ab belongs to r. Now, here is real part of the complex number, and b is imaginary part. So complex number is noted by a plus iota b. Here real is a is real part, b is imaginary part of a complex number. For example, I have the complex number say 3 plus 4 iota. Here real part is 3, imaginary part is 4. I have complex number iota minus 2. Here real part is minus 2, imaginary part 1. I have a complex number 2 root 2 iota. Here real part is 0, imaginary part is 2 root 2. So these are the cases of real and imaginary part of the complex numbers. Hope it's clear. Now we have the addition of the complex numbers. Now in addition, if I take up the two complex number a plus iota b plus c plus iota d, so the addition of two complex numbers, the addition of the real parts plus addition of the imaginary parts. So this is 2 plus 3 iota plus 1 plus 4 iota. Suppose I want to add. So it's nothing but it's 3 plus 7 iota. Also, if we take 3 plus 6 iota minus 1 plus 2 iota, well, that is 2 plus 4 iota. So this is the addition of the complex number. This is the subtraction of a complex number. You can have the operations by this type also, addition as well as subtraction. Now class comes multiplication of complex numbers. See, in multiplication of complex numbers, you will multiply two complex numbers, a plus iota b, c plus iota b. So this is AC plus AD iota plus BC iota plus BD iota square. You can apply distributive law and ordinary law of algebra that you can, from complex number iota into multiplied by any scalar, you can take scalar out. So this is AC plus AD iota plus BC iota minus BD. So this is AC minus BD plus iota times AD plus BC. Likewise, you can multiply two complex numbers. Suppose you want to multiply 2 plus 3 iota, 1 minus 6 iota. So this is 2 minus 12 iota plus 3 iota minus 18 iota square. So this is 2 minus 12 iota plus 3 iota minus 18 into minus 1. This is 20 minus 9 iota. So the product of these two complex numbers is 20 minus 9 iota. Now in the same way, if you have 1 minus 2 iota into 2 plus 3 iota. So this is 1 into 2 plus 3 iota minus 2 iota into 2 plus 3 iota. This is 2 plus 3 iota minus 4 iota minus 6 iota square. This is 2 plus 3 iota minus 4 iota plus 6. This is 8 minus iota. So the proper answer is 8 minus iota for this. So this is how you multiply two complex numbers. Now in the same way, if I were asked to find the value of iota's power 4, now that will be iota square whole square. This is minus 1 square, that is 1. Iota's power 6, this is iota square is to power minus 3. This is minus 1 cube, that's minus 1. Now you have 1 plus iota is to power 100. Suppose I want to get this value of this. Now you have 1 plus iota whole square is to power 50. Now this is 1 plus iota square plus 2 iota is to power 50. Now iota square is minus 1. So this is 1 minus 1 plus 2 iota is to power 50. So this is 2 raised to power 50 into iota to power 50. Well, this is the ordinary law of indices. So this is 2 raised to power 50 into iota square is to power 25. So this is 2 raised to power 50 into minus 1 is to power 25. So this is minus of 2 raised to power 50. So the value of 1 plus iota is to power 100 is minus 2 is to power 50. Hope it's clear. Okay, in the same way, if I was asked to find the value of 1 minus iota is to power 80, you will write 1 minus iota whole square is to power 40. This is 1 plus iota square minus 2 iota is to power 40. This is 1 minus 2 iota is to power 40. So this is minus 2 iota is to power 40. This is minus 2 is to power 40 into iota square is to power 40. So this is 2 raised to power 40 into, and this is is 20. Minus 1 is power 20. That is 2 raised to power 40. So its value is 2 raised to power 40. Likewise, you can have many problems like this. You can solve it. One more problem, I can discuss it now. Find the value of 1 plus iota is to power, say, 4. So this is 1 plus iota whole square. This is 1 plus iota square plus 2 iota is to power square. So this is 1 minus 1 plus 2 iota power square. This is 4 iota square. That's minus 4. So value of 1 plus iota power 4 is minus 4. Now, if I write complex number as 2 plus 3 iota, this I can write it 2 plus 3 into root of minus 1 also. So usually we apply this notation. This notation can be given in exams, but usually just to confuse yourself, we sometimes apply this notation. Otherwise, you can have this notation for this complex number. So I told you the multiplication also. So also you take care that when a iota power k is even, greater than k is greater than 2, then if k is greater than 2, k is even if you take it equals to 2, you have iota is to power say k is greater than 2 iota square is minus 1, iota's power 4 is 1, iota's power 6 is again minus 1, iota's power 8 is 1. So you have the conclusion that iota's power 4k plus 2 is minus 1, iota's power 4k is 1, where you can say k is whole number. So we have this result to be remembered. Iota's power 4k plus 2 is minus 1. Iota's power 4k is always 1. Please check it out, and any doubts you let me know for this. So within 1 or 2 days I will take next class of complex numbers, and I will sort out your some doubts of set theory where you asked to prove some identities and some of your doubts. Thank you.